Good afternoon. Welcome to Human Holograms 101. I am Josh Silverman. I am a software engineer with the Microsoft Mixed Reality Capture Studios. We capture human holograms. And this slide shows the crazy range of holograms that we've created over the past several years. In the next 20 minutes, I want to cover three primary topics with you. First, what is a hologram and how might we use it in our MR experience? Then we will talk about the creator experience. How do we capture and actually create one of these holograms? Finally, the developer experience. How do we integrate these holograms into your mixed reality application? So first, what is a hologram? Well, here you see WWE superstar AJ Styles as a hologram. He looks like video, but he exists in full 3D, so you can see him from any angle. This is what it usually looks like when I open up a hologram in our review app. I can view the hologram from any angle. He's actually spinning around here, and he looks pretty great. Come on, back around. There he is. But here's what it looks like when our partners integrate holograms into their experiences. There is a wide variety of holographic content out there in the marketplace already that we have helped to produce. Some of that, from the top left and moving clockwise, includes Sir David Attenborough exploring fossils in a virtual British Natural History Museum. You can see here an immersive VR storytelling experience. There's Reggie Watts as a HoloLens application. You can see here Peyton Manning in a Gatorade brand activation. You can see an example of us putting an actor portraying medical symptoms into a real-world setting using the HoloLens, and then students are able to diagnose the ailment. You can see Billy Corgan of the Smashing Pumpkins. He shot a music video with us for his most recent solo album. The song was Aeronaut, and it's coming out soon as a VR experience. And there was a Blade Runner 2049-based VR experience which accompanied the release of the film. Most importantly, we've captured some personal memories, like our general manager Steve's kids, and played them back in an app, an AR app, on a mobile device. I love showing people this demo in person. It's usually the aha moment that they need to really understand how these holograms can be used. So, it's time to create a hologram. What does that production timeline actually look like? Obviously, we start with the concept, and then our stages work through pre-production discussions in order to turn, we work with our clients to turn their concept into a hologram and plan out the rest of the production schedule. We cover issues like hair, makeup, and wardrobe, because flyaways and wispy hair does not capture very well as a hologram. It also does not play back very well. Reflective makeup, wispy, loose clothing also doesn't really work. So we work closely with our clients to make sure that they're capturing something that makes sense. Then we do a test shoot day, if appropriate. Finally, the shoot day. And then our technical artists that associated with each stage will iterate through the content as it moves from captured content into the deliverable hologram format, which gets delivered to our developers who do whatever post-production they need on it and then integrate into their applications. So here's a picture of our Redmond stage. There's also a stage in San Francisco. That's where I'm from. There's also a partner stage. Our partners, Dimension Studios in London, have a stage. And we're opening another stage soon in LA. A stage consists of 106 synchronized cameras. That's 53 IR and 53 RGB cameras. They are arranged into stereo pairs. They're each 4 megapixel sensors, and they typically capture at 30 frames per second. Although for just twice the processing time and twice the storage, we can capture at 60. Now, we use stereo pairs to get depth information from our cameras using stereo photogrammetry. We do not include any actual depth cameras on our stages, but we do project infrared noise onto our subjects to give the IR cameras a little bit more data to work with. Tiago calls out rolling, Spencer calls out action, and it looks pretty much like any other regular video shoot. Here you see Maori haka dancers. This is one raw frame from each of 53 different RGB camera viewpoints. Now, not every camera needs to capture the entire subject, but that's fine. We do have cameras overhead, which you can see there on the right column, but not from underneath, as they would interfere with the footwork of the performers. Some people say, well, what happens underneath? We can't capture what's going on from the bottom. Well, if the camera can't see it, your MR experience viewer probably can't either, unless they're rolling around on the floor. So, this pre-processing that we do to our content before delivery, what does that actually consist of? Well, we typically take the camera inputs, 106 cameras, we remove the background, we turn that into a point cloud, we turn the point clouds into a mesh, we turn each individual mesh into sequences of tracked meshes, which I'll explain in a moment, and those tracked meshes get compressed into free viewpoint video or an MPEG-4 file, which we deliver to you. So not every frame gets a fresh mesh. By maintaining consistent topology within groupings of frames, we're able to get consistent UV atlases between frames, which allows us to do temporal compression on the textures and get a much smaller file size, which is especially useful if you're targeting something like the HoloLens. So what is a hologram deliverable? What does that file actually look like? I'm sure you're dying to know. How do you actually use this thing in your application? Well, the deliverable can be one of two packages. First, we can deliver a sequence of OBJ and PNG files that you are free to flip through in your application however you want. However, in order to leverage some of our special magic that we can do in our processing, we also compress down to an MPEG-4 file with embedded mesh data. That's a proprietary format, but we also deliver scripts and plugins for your favorite development environment so that you can consume these things super easily. You can see if you're targeting something with lower resolution and that can handle maybe a lower bit rate, on top we can set parameters at compression time. Actually, it's as we're processing these holograms, we can set things like poly count and texture size. So a 10K poly and 1K texture typically yields about 50 megabits per second as an OBJ or PNG sequence. That may sound reasonable as far as volumetric data goes, but when we compress down to an MPEG-4, we get that down to 24 megabits per second. That's on the lower quality end. If you're targeting something like the Samsung Odyssey and you want a higher quality product, we can use 80K polys, 2K textures, and even though that would be nearly 2.6 gigabits per second of data as a sequence, it compresses down to about 65 megabits per second as an MP4. The difference in quality is really noticeable when you get close to a hologram. Typically, you may shrink them down, view them from afar, but when you get up close, you start to notice some artifacts at the lower bit rate. For instance, here on the left, you can see some artifacting around the soccer player's shirt, especially in the middle and the bottom left, whereas these artifacts are much less pronounced at the higher bit rate. So what platforms do we support out of the box? Well, definitely Unity. We like Unity on Windows, Mac OS, iOS, and Android. If you're using Unreal for your project on Windows, you can import this content using our plugin. We also support native iOS and Android and Windows, which gets you access to things like SceneKit, ARKit, ARCore, whatever you want. Now, it's time to integrate into a game engine. Our dedicated plugin makes integration a snap. You can apply shaders and post-processing and treat them just as you would any other game object. I should point out that although these are human holograms, we do not support skeletons or other rigging that you could use for animation. There's also limited physics interactivity because our plugin delivers the assets, the meshes and the textures at a point in the pipeline in the GPU after which they could be used as colliders. So you cannot natively use these things as colliders. But one technique people have used is to pre-process those OBJ sequences into lower poly count OBJs, well, meshes. And you can flip through those downsampled OBJs to be used as colliders if you need them. What does it look like if you want to initialize these things programmatically? Well, in Unity, you would just create an instance of the prefab, grab the holo video object, which is a script that we provide. That gives you access to open a hologram and then transport controls like play. And that's it. Our script will copy the hologram to native vertex and index buffers, native textures. It renders in the scene just like any other game object. It casts shadows, and it can be affected by lighting. The script will automatically update frames as necessary while playing back. Here's what it looks like in the Unity GUI. We import the plugin, drag in the prefab to the scene, position it as necessary, specify the path of the hologram file, and start the game. That's it. It is similarly simple in Unreal. Oh, I was hoping you could hear him kicking the soccer ball around, but I assure you, we also support audio. The audio can be embedded as in the MPEG-4 file, just like it would in any other video file. What are your options when it comes to lighting your hologram? Well, you have three options, really. First, we can capture with contextual lighting on the stage. For instance, if you know that your subject will be placed in a VR environment where he is lit from the side, well, we can light him from the side when we capture the guy. Another alternative is to use baked-in lighting in the textures. A lot of people have been pre-processing these texture sequences and baking the lighting in there. You get some pretty high-quality results. But another alternative is to do dynamic lighting using the vertex normals that we embed in our meshes during the iterative processing pipeline. That gets you some better interactivity, and it's certainly easier than pre-processing the textures or lighting the scene as you would on the stage. Here we see our soccer player again. This is with neutral lighting that we used just when we captured him. Then, in a different environment, which includes dynamic lighting from the right side, notice the shadows cast by his arms on his torso. Something that's been coming up recently is the issue of gaze retargeting. Now, a lot of our subjects are reading on the stage. They're reading off of a teleprompter, so their gaze is very static. Wouldn't it be great if once you moved these holograms into a VR experience, the gaze of the presenter could follow the eyes of the VR viewer? Well, that would get you much better interactivity between hologram and viewer. So here you can see Lucas's gaze tracking an axis indicator in real time. Of course, if you animate this sort of thing too far, you get into the uncanny valley pretty quickly. But by manipulating the mesh in the render engine, we are able to use gaze tracking pretty effectively. So I'm really hoping that you're all going to go back to your respective companies after build, and you're going to get a call one day, and your client is going to say, hey, I really want an asset, a video, well, a hologram, some sort of animated asset in our next game that looks like Will Smith. Now you have two options. You can tell your animators to try to come up with an asset that they'll animate and try to get to look kind of like Will Smith, or you can book some time for Will on a Microsoft mixed reality capture studio stage, and we can actually capture the guy giving a performance that you can easily drop into your VR experience. I think you'll agree the latter sounds like a lot more fun. So the takeaways today are, I hope you understand that this is a real technology. This is ready for prime time. You can call us and book time on the stage right now. These assets are useful across MR, VR, AR, and 2D devices. It's easy to capture, and the capture process looks just like a video production process. These assets are simple and lightweight for deployment, and we bring the value of human connection to your experience. If you are interested in using human holograms in your next project, you should visit us at this URL. Please do give us a call. We will discuss your project, your creative goals, your time frame, and definitely your budget, and determine if it's a good fit. We hope that you will give us a call. We'd love to hear from you and help bring your next project to life. Thank you. Don't forget to evaluate this session. Thanks.